Hello, welcome to our YouTube channel Civil and Structural Engineering Automation Ideas. I am Chandrakant Kulkarni. I have more than 39 years of experience in detail design and engineering. My expertise is in the detail engineering of residential structures, commercial structures, and infrastructures, including bridges, tall chimneys, storage silos, natural draft, induced draft cooling towers, industrial structures, oil and gas industry, metal and mining industry, and many more.
Hi, I am Nikhil Kulkarni. I have completed my master's in structural engineering and have been working as a structural engineer for past 14 years. My experience is in residential and commercial structures, industry structures, infrastructures like bridges, water treatment plants, sewage treatment plants, effluent treatment plants, and others. I have also worked in oil and gas industry and some blast resistant structures.
Our last video 1, the link for this video is provided in this video. We introduced how we can automate the solution for rectangular footing subjected to biaxial bending and octagonal footing subjected to bending. In actual design, there are multiple load combinations for which the following checks should be carried out for an individual footing. Check foundation against sliding and overturning with appropriate safety factor, say 1.5 or 2. Check the foundation for gross bearing pressure at the founding level. Gross bearing pressure is calculated by adding soil overburden to net safe bearing capacity at the founding level. Check the foundation for a certain percentage of contact area. This area is maintained at about 75% of the total footing area. This would be defined based on the project design basis requirement. As the footing needs to be checked for multiple load combination, it is not practical to check the foundation for every load combination. In this case, we resort to automatic calculations. This video demonstrates how the program in video 1 is being used to automate foundation checking for multiple load combination. Two Excel worksheets or workbooks rather are required on the computer. Number one, Excel workbook that contains two different sheets, each having a tabulation of various SLS and ULS load combination with various load factors. Now here is the Excel sheet which is open, which indicates the basic load cases, around 8 or 9 basic load cases from one of the projects we're sharing here. And then we have another sheet called SLS load combination and one more sheet called ULS load combination. Now these load combination sheets are having various load factors for individual load cases, and then each Excel sheet, load combination sheet rather, is defined uh, based on what type of load combination it is, whether it is SLS combination or ULS combination respectively. Excel number 2 sheet contains Excel workbook which contains support reaction at base plate level. This workbook also contains either two different sheets or a single sheet containing support reaction for SLS and ULS load combination. Here two different sheets are considered with name SLS combination and ULS combination. Right. Let us start with our program now. Now there's a button called foundation analysis. The this Excel sheet has a button named foundation analysis. We click on the button. Once this button is clicked, a form is populated. A form pops up on the screen requiring foundation data to be filled. So we are filling up the foundation data here. Right, say width of the foundation is 2 meter, length of the foundation is 2.5 meter, depth thickness of the foundation is 0.5 meter, pedestal size is 0.6 by 0.6, finish grade level is 0, then top of concrete for the plinth is 0.3, founding level is minus 1.5, water table level we are considering as minus 3 meters, then water density as we are aware 10 kg per meter cube, concrete density 25 kg per meter cube, then soil dry density 18 kg per meter cube, soil wet density 21 kg per meter cube, and we are considering angle of internal friction of 27 degrees. Here coefficient of active earth pressure, passive earth pressure, then pressure at rest and coefficient of friction are at user discretion. If we are using the angle of internal friction to calculate the uh, all these parameters, we can keep this blank, or we can fill those values as appropriate. Here we are considering angle of internal friction to calculate the active earth pressure, passive earth pressure, and then earth pressure at rest, etc., etc. So we are not considering these values. So we're keeping these values as blank. We're considering bearing pressure, net bearing pressure at 300 kilonewton per meter squared. Gross bearing pressure will be calculated automatically. We're considering the factor of safety of for sliding and overturning as 1.5. We're considering the percentage contact at 45% for sake of our convenience. Then concrete cylinder strength of 30 newton per mm squared. Grade of steel is we are using FY 416. Then elastic models of rebars we are using 210 kilonewton per mm squared, and we are considering the passive resistance here for checking on sliding check. Now let us click on the button OK. Then once we click on the button OK, it will ask for the load combination files. So we go to the Explorer, we select that particular file, basic load and load combination, then say OK. It picks up the file. Then it will ask for another file wherein we need to supply the support reactions for SLS and dual phase combination. The file containing SLS support reaction is we can see on the screen. We select that file, open it, and then the program starts doing calculation in the background. It will take a while to do the calculation, as this is doing a sort of iterative procedure. It will take a while to come to a solution. So we wait for the final answers. May take 5 minutes. Depends on how much data we need to process. If the data is small, the time required will be small. If the data is big, the time required will be big. And also, if at the first instant, if we are doing the appropriate footing sizes, we may end up quickly. If our foundation size are not adequate, it may come out of the program indicate giving the warning that footing sizes are inadequate. So it will automatically check all these criteria which were defined for sliding, overturning, gross bearing pressure, and percentage contacts. So let us see how this program works.
While the program works, let's try and understand uh, a few basic details here. So, why would you say we use Excel for this particular type of program?
Excel is very easily available on almost all the machines. So it is, I would say, it's quite universal sort of a software which is available on all Microsoft machines. So that will uh, give us a very quick access to VBA, and there are a lot of functions in VBA which help us to solve this type of trial and error problems quickly.
Excellent. So, given this background, we can actually see that the Excel is a very handy tool which helps us in automation, uh, big volumes of data. See, if we were actually doing all these calculations manually, it would have been very time consuming, and rather a lot of things might have been missed, because it will definitely, when humans are involved, there is a very large scope for error. So given that we are able to automate this, I think Excel is a very uh, uh, ideal choice for this type of iterative processes.
That's right. Let's wait for the results. Perhaps it may take 5 7 minutes, I believe.
So what are a few of the projects that you are currently working on? We would like to know that.
We're working on various projects. Rather, I'm thinking that we'll be providing another further to this program. We'll have add-on wherein we'll be showing how do we quickly design the foundation, say isolated footings here for say the pressures. Now we definitely we are going to have pressure values in under ultimate condition. So we'll check the foundation and design the foundation for the this bearing pressure. We calculate the reinforcement. We check the foundation for the one-way shear and two-way shear. We check the adequacy of the reinforcement which we are proposing as a trial to indicate whether the foundation reinforcement is adequate, thickness is adequate for all the criteria like say punching, one-way shear and flexion. The next thing which we are planning is will demonstrate on how we calculate the pedestals or like say column design, particular rectangular columns which are subjected to biaxial bending and compression or tension. Oh, sorry. So we can now see sheet one wherein we are finding all these checks have been carried out, and we see the foundation is checked for almost everything, every requirement, and it shows clearly it's okay. It should indicate percentage contact. It show the neutral axis, then with the neutral axis orientation with the horizontal at a certain axis, certain angle rather, and then it indicates the foundation size is okay from all the checks like sliding, overturning, then bearing pressure, etc. Similarly, we have checked the foundation for ultimate load combinations. Also, we are checking here only the maximum. We are not checking anything here except we are calculating the bearing pressure and percentage contact and the neutral axis. Of course, this percentage contact and neutral axis we are not using it at all. We are just trying to find out the maximum pressure that could be developed due to loss of contact, which is generated here as we can see.
I think yes, this is an excellent demonstration of how powerful the Excel is and how easily it can help civil engineers, especially structural engineers, to quickly analyze and design the foundations and all the other components of the structure. Thank you for your time.